Alright, this video is going to go over how we're going to make conversions between moles and grams. We're going to use the formula that's on the New York State chemistry reference tables. There's other methods to doing these calculations, such as using dimensional analysis, but we're just going to focus what's given to us in the reference tables to start. So from the activity in class, you should know at this point that 1 mole represents a unit, just like 1 dozen represents 12 bagels. 1 mole represents the 6.02 times 10 to the 23rd particles. So if I have 1 mole of helium, I have 6.02 times 10 to the 23rd atoms of helium. Or if I have 1 mole of water, then I have 6.02 times 10 to the 23rd molecules of water. Also, when we've been adding up GFMs, we've been writing units as grams per mole. So that allows us to figure out how many grams of that sample is equivalent to a mole, which then also helps us relate it to particles. So on reference table T, you're given this formula where the number of moles is equal to your given mass in grams divided by your gram formula mass, or GFM, in grams per mole. So in the first two calculations, we're just going to simply determine the number of moles of a given mass of a specific compound. So for the first one, we're using sodium hydroxide. So it says determine the moles that present in a 60-gram sample of sodium hydroxide. So whenever you're going to be involving moles and grams, you're going to need the GFM. So we've done this since the beginning of the unit. You're going to add up the GFM using your periodic tables to get 40 grams per mole. Then it's just a matter of plugging everything into this new formula. So moles is equal to grams divided by GFM. The given mass was 60, so it's going to go up in the numerator. And then my GFM that I calculated, is 40. So when we plug that in, we have 1.5 moles. So that means if I have 60 grams of sodium hydroxide, say on the balance in the lab, I would know that I have 1.5 moles of sodium hydroxide, and then that would influence different calculations I would be able to make in terms of what it would react with, how much product it could make, that type of thing. All right, in this second example, you can determine the number of moles present in 42.4 grams of strontium nitrate. So again, because we have moles and grams, and we're going to use this formula, moles is equal to grams divided by GFM, we need to add up the GFM of strontium nitrate. Just be careful, remember you have 2 nitrogens and 6 oxygens there. So when I added that up, I got 211.64 grams per mole. So then when I plug that in, along with the given mass that they gave me, I find out I have 0.2 moles of strontium nitrate in that 42.4 grams of strontium nitrate. Now, a lot of the times you have to actually find the grams for a given amount of moles. So you can still use the same formula, we're just going to manipulate it. So you can either plug it in this part, or you can change it around to solve for grams and then plug your information in. So we're going to use this for the next 3 calculations. So here they want us to calculate the mass of 1.5 moles of calcium fluoride. So in this case, I'm going to just start with how I have it. Sorry. So I have my 1.5 moles that they gave me. I don't know the mass of it, but I do know my GFM based on the formula. Then imagine, most of you guys will do this, where you're going to put it over 1 and then just cross multiply. So 1.5 times 78.08, when I multiply those together, I get my 117.12 grams. Here we're going to do another example, calculate the mass of 0.75 moles of the magnesium hydroxide. So we're going to plug in our 0.75 moles. I added up the magnesium hydroxide to get 58.33 for the GFM. And then when I cross multiply to solve for X, I have 43.75 grams. All right, and then for the final calculation in this section of your note packet, calculate the mass of 2.25 moles of copper 2 sulfate. So I added up the GFM. Based on the periodic tables, I plug that into the GFM spot in the formula. I then plug my moles in that were given to me. I cross multiply, and then I get my final answer. That 2.5 moles of copper 2 sulfate would be equal to 359.15 grams of the compound. So it's just a matter of recognizing that when you need to use this formula, whenever you have moles and mass, and then being able to calculate the GFM, and then get it all plugged correctly into the formula so that you can calculate either moles or grams of your element or compound.